Okay, uh, now let's look at one of the most important concept in this section. What actually changes when we move from VCF 9.0 to VCF 9.1? I don't want everyone to look at this slide as simply as a list of new features. So instead, look at it from an operations team's point of view. In VCF 9.0, we already have a strong software defined infrastructure, but there are still areas where administrators have to deal with hardware limitations like separate operational workflows, manual sizing, or different security models. So here VCF 9.1 tries to remove some of those operational boundaries. So on the left, we have our VCF 9.0 baseline. On the right, we have the VCF 9.1 evolution. Let's take this four areas one by one, and more importantly, we'll understand what problem each enhancement solves in a real production support environment. So the first one is memory and NVMe tearing. Okay, so here the point we need to understand here is about reboot required. So the basic idea is very simple here. Normally, our primary memory is our dynamic RAM. So DRAM is extremely fast. We everyone knows about that, right? But it is also very expensive. Okay. So if our ESXi host has a fixed amount of DRAM, eventually, we reach a point where we cannot keep adding more memory economically. Here, VCF 9.1 introduced enhanced memory tearing, where NVMe can be used as an additional memory tear. Think about it like this, suppose we have an ESXi host with 512 GB of physical RAM, but our workload demand is much higher. So not every memory page is equally active, right? So some pages are extremely hot and need very fast DRAM access. Other pages are relatively cold. They are not being accessed frequently. Here the tearing mechanism can keep the hot data in DRAM while moving colder pages to NVMe. When I say colder pages, which is not accessed very frequently. So here we are effectively extending the usable memory capacity of the host. So I'm going to explain this with a production example right now. Now let's do an imagination. Just imagine a production database server which is running on a VCF cluster. So if you look at this image, during normal business hours, the database workload requires a large amount of physical memory. Previously, the infrastructure team might say, we are running out of memory. We need to add more physical RAM or dynamic RAM or to buy large servers. But with memory tiering, we have another option here. The ESXi host can use NVMe as the secondary memory tier and intelligently place colder memory pages there in the NVMe. So instead of immediately purchasing additional high cost DRAM, we can better use of the resource already available in the host. If we have NVMe drives, we can use that. That's the most important operational benefit we need to understand here. The objective is not to make NVMe as fast as DRAM. The objective is to increase effective memory capacity and improve VM density without immediately adding expensive or DRAM. So when we see RAM plus NVMe on this diagram, just remember DRAM is the first tier, NVMe becomes the additional tier. That is the concept we need to understand here. Okay. So instead of buying large servers or instead of spending more cost on the RAM to meet our requirement, we can use the NVMe drives which is there in that ESXi host to act as the memory. So that is the concept you need to understand here. Then let's move to that next one, like hardware locked replication. So that is evaluated as multi-source replication in VCF 9.1. Okay, so this one is particularly important when you work with production environments that have evolved over many years. In VCF 9.0, vSAN to vSAN replication provide protection between vSAN environments. But the reality in enterprise environments is that customers don't always have only vSAN, right? They may have vSAN, they may have VMFS, they may have NFS, or some other old storage platforms. So different clusters at different sites will have different storages. Now, VCF 9.1 expands this with multi-source replication. So VMs from different storage sources can be protected to a vSAN target, including vSAN, VMFS, and NFS sources. It also supports a fan-in model where multiple source clusters can replicate toward a central recovery site. I'm going to explain this with an production example. So as per this image, there is a company with 3 data centers. If you look at this image, data center 1 has a new vSAN cluster. Data center 2 still has workloads running on VMFS storage. Then data center 3 has some legacy application running on NFS. Now, the disaster recovery team wants one recovery site to replicate all this storage related stuffs to a single site. Okay, so in a more hardware dependent model, the storage architecture can become a major consideration. So with multi-source replication, the recovery design becomes much more flexible in VCF 9.1. Here we can have vSAN to be replicated to vSAN recovery, VMFS source storage can be replicated to vSAN recovery, and NFS source again it can also be replicated to vSAN recovery. So multiple production environments can feed into a centralized recovery point. So that's what the concept on this diagram is showing here. Multiple sources, that means multiple storage coming into one recovery target. So for a production architect, that's a big deal, right? Because we don't have to redesign every existing workload simply because the underlying storage platform is different. So just remember, this is just a replication feature. Okay. So this is one of the new concept which has been introduced in VCF 9.1.